Hey guys, this video is going to go over adding and subtracting polynomials. We're in Unit 1. Our essential question is, what is a polynomial and how is it classified? Alright, so before we can actually go what polynomials are, we want to actually remember what terms are. So remember that terms are separated, oops, let's get some nicer handwriting, right? Are separated, struggling a little bit today. It is a Monday, so separated by plus and minus signs. And we kind of talked about this when we were first simplifying equations and solving equations and going through the steps of combining like terms and all of that. So today we will also be combining like terms, but also being able to classify polynomials. Alright, so let's go ahead and go over our new vocabulary words, which are 3 brand new ones that we've never really talked about or heard before. So we have monomial, binomial, and trinomial. So you'll notice that the prefix of these 3 words actually indicate kind of what they mean. So mono means 1. Bi means 2, and tri means 3. So a monomial is something that is just one term. Okay? Binomial would be 2 terms, and a trinomial would be 3 terms. And I'm going to go ahead and give examples of all of these. So an example of a monomial, okay, remember terms are separated by plus and minus signs. So it can be as many numbers and variables as you want. So 5x is an example of a monomial, or 3x squared, or 7xy. These are all a single term. Okay, some examples of binomials. Remember, they're separated by plus and minus signs. So 5x minus 3 could be one, or 7 plus 3y squared. That's a binomial because they're separated by plus and or minus sign. And then I'll go ahead and give you just one example for a trinomial. Remember that is 3 terms, so 5 minus 2x squared plus 9x. That could be something that is 3 terms. Now, what is a polynomial? Now, a polynomial doesn't mean 4 or more. It actually could be any of the above. It could be a monomial, a binomial, or a trinomial. So a polynomial in general is actually just 1 or more terms. So really, all of the above are polynomials. All of them are. So you're like, okay, well then why do I have to call them all these different names? Well, when something's 1, 2, or 3 terms, they get a special name, but they're all considered a polynomial. So for example, right, dogs is a general term, but there's different types of breeds, right? There's golden retrievers, there's German shepherds. So you're just specifying if they have 1, 2, or 3 terms. They're all polynomials, but when you have 1, 2, or 3 terms, they have special names. So for those dogs are all dogs, but they do have different types of breeds. So it's kind of like the same concept. All right, now what is a degree of a polynomial? Now this is something new, we haven't talked about this before. The degree of a polynomial is the highest, let me actually use a different color. Let's use purple. The highest exponent in the polynomial. Okay, so it's the highest exponent in the polynomial. And I'm actually going to give you an example. And we'll talk about what that degree is. So I'm going to give you the example of 5x squared minus 3 plus 8x to the 7th plus 1003x. Okay, now this is our example here. And let's talk about this. Well, what's the highest exponent that's going to tell us the degree? Well, the highest exponent I see here is a 7. So this is a 7th degree polynomial. If the highest exponent was a 5, it would be a 5th degree polynomial. All right, and then standard form of the polynomials. It's going to be a super lengthy definition, but it's actually not that difficult to do, so we'll talk about that, but I'm going to go ahead and define it. The standard form of a polynomial is the order of the terms. Sorry, I'm struggling with writing. I'm so sorry for the extra tapping. With the greatest exponent to the smallest exponent. Okay, So it's the order from the greatest exponent to the smallest exponent. So I'm actually going to use that previous one as the example here. So I'm going to use this as the example, and I'm going to bring it down. Let's use like, I don't know, this lilac color. Example. Right? I'm going to use that as the example. So I'm going to order this in standard form. The green polynomial is not in standard form yet. So you want to start with the greatest exponent, the highest exponent. And in this case, it would be the term 8x to the 7th, because the 7 is the highest exponent. So let me move this so it's not on like a line. So the first term would be 8x to the 7th. That's the highest exponent. Well, what's the second highest exponent? It's that 2, right? This 2 right here. So that's the second highest, so that would come next. Now, because this is a positive term, we want to make sure we put that plus sign there, so 5x squared. And now the next highest exponent, well, now you have 2 terms left. You have the negative 3, and then you have the positive 1003x. Well, the one that's the higher exponent is the one that actually has the variable, because the one that doesn't even have a variable has an exponent of 0. And remember, when it's not written, there's technically a 1 there. So it's actually an exponent of 1, and the 3 would actually have an exponent of 0. So the next term would be positive 1003x, and then lastly, negative 3, minus 3. So that's the order from the previous problem. So I used the previous example, and I just put that in standard form order. Okay. So now we're going to get into classifying polynomials. So before we get into adding and subtracting, we want to be able to classify these, okay, and talk about their degree. So remember, the degree is the highest exponent. The classification is whether it's a binomial, a trinomial, monomial, or if you can't give it a special name, then you just call it a polynomial. So if it's like 7 terms, you call it a polynomial, because there isn't a special name for something with 7 terms, but there's special names for things with 2 terms. Okay, so for the following expressions, determine the degree and classify the polynomial. Then put it in standard form. And remember, standard form, you go from the highest exponent to the lowest exponent. So we're going to do number 1 first. 7 plus x to the 5th plus 3x cubed. Now, let's talk about this. What's the degree of this? Remember, the degree is the highest exponent. The highest exponent I see here is the 5. So this is a 5th degree. Okay? And then I want to classify it. So this is going to be based on the number of terms. Well, here I have 3 different terms, so this would be considered a trinomial. Yes, it is technically a polynomial, but because it has 3 and there's a special name for it, we want to give it that special name. So a trinomial. And then we want to put this in standard form. Remember, standard form is the highest exponent to the lowest. So the highest exponent here is the 5. So the x to the 5th would come first. And then the positive 3x cubed. And lastly, the positive 7. So that would be standard form. All right, moving on to number 2. You want to talk about the highest degree, and the highest exponent I see here is the 2. So this would be a 2nd degree polynomial. But more specifically, when we classify this, we notice that there's 2 terms. Well, because there are 2 terms, we give it that special name of a binomial. Okay? And then next, we're going to put it in standard form. You always start with the highest exponent, so that would be this term. Now, be careful because this term is negative. So you want to make sure you include that minus sign in the front there. So negative 5x squared. And then the next term that would come after it is the 8x, and that is positive, so you want to make sure you state that it is a positive 8x. So you're basically just reordering the expression. You're not changing it in any way. You're just rearranging it. All right, number 3. Okay, we're looking for the degree, so that's going to be the highest exponent here. In this case, it would be the 7. So this would be a 7th degree. Okay, now can we give this a special name? Well, it looks like we have 5 terms here, and there isn't a special name for something with 5 terms, so we just call it in general a polynomial. Oops, I need to make that yellow to match the rest of them. Okay. Okay, and then we want to put it in standard form. You always want to start with the highest exponent first, and if it helps, you can cross them out as you go. So the first highest exponent I see is that 3x to the 7th, so that would come first, positive 3x to the 7th. And again, you can cross out as you go. And then the next highest exponent I see is the 5 here, so I'm going to put 4x to the 5th. Now the coefficient, the number in the front does not matter, right? We're looking at the exponents, and that's how we order them in standard form. So that one's done. The next highest I see there is the 3 exponent, so it's going to be negative 8x cubed. And then the next highest exponent I see is going to be a 1 because the x here has a 1 exponent. Remember, this has a 0 as an exponent, so it's not there. So we have positive 7x and then minus 2. So we ordered the 5 terms from order of the highest exponent to the smallest exponent. All right, so now we're actually going to get into adding and subtracting polynomials. Now, the process is actually not too bad. You're just going to be combining like terms and then putting it in standard form. So we'll go ahead and start. Now, with number 1 here, you'll notice you have parentheses. Now, we've learned about how to get rid of parentheses. Well, how do you get rid of parentheses? You distribute the number that's usually attached to the front. Well, what number is really here then if it's not written? It's a 1, right? And same thing with this set of parentheses. There's technically a 1 there. Now let me ask you, when I multiply something by 1, does anything change inside? No. So is it necessary for me to actually have to distribute a 1 through this whole entire thing? No, not really, but if it helps you not make mistakes, then I would encourage it. So, for example, 1 times 4x squared would just give me 4x squared. So I'm getting rid of the parentheses, not really having to do anything because 1 times anything is just whatever there was. And then again, 1 times 3 would just be positive 3. So distributing a 1 doesn't really change anything, right? Positive 1 times 3x is positive 3x. Positive 1 times 7x squared is positive 7x squared. Positive 1 times negative 1 is negative 1. So nothing has really changed because distributing a 1 doesn't change anything. So then once you've gotten rid of all your parentheses, you're now allowed to combine like terms. So you want to go look for your like terms. Remember that like terms have the same exponent and the same variable. Same exponent and same variable. So one set of like terms I see here is 4x squared and positive 7x squared. And if I were to combine those, I would get 11x squared. Now we're just combining here. Now you'd be like, well, not on the same side. Well, like with an equation, you're only allowed to combine them if they're on the same side. However, this is not an equation. So you're just basically pushing them all together, simplifying it, combining them if you can. There are no sides, so you shouldn't be like subtracting or adding anything from side to side because there aren't any sides, okay? All right, and then the next thing I see, do I have any other like terms? I do have other like terms. Hopefully you see them. Positive 3 and negative 1. Those are like terms. They're just regular numbers and you can combine them. Positive 3 and negative 1 make positive 2. And then lastly, I have that 3x and I'm not able to combine it with everything. So what do? I just put it onto the back. Now we're almost done here, but we want to go ahead and put it in standard form because that's good math skills, math habit? Yeah, it's a good habit to do. So we're going to go ahead and put this in standard form. Remember, standard form, you go with the highest exponent first. In this case, it would be that squared exponent, so it would be 11x squared. The next highest exponent would be the 1 exponent on top of the x here. So 3x would come next, so positive 3x. And then lastly, we have positive 2. Now, is your answer wrong if it's in the other form? No, but if it's asking for standard form, you want to make sure that you're able to put it into standard form. Okay, moving on to number 2. Now here we have 2 sets of parentheses again. I'm going to go see how can I get rid of those parentheses. Well, to get rid of these parentheses, I would distribute the number that's attached to the outside of it. Well, in both cases on these parentheses, the number I have on the outside of both of these parentheses is a 1 because it's not written there. Remember, when I distribute or multiply by 1, nothing changes on the inside. So really, I have the exact same thing, but now I'm not restricted by those parentheses and they're gone. So I have positive 8, negative h, and then negative 3h squared. All right. Now from this step, you're going to combine like terms. Now, do you see any like terms that you could combine? Possibly? Probably, right? So I see here I have 3h squared. And remember, like terms have the same letter and the same variable and the same exponent. So you see here that a negative 3h squared would also be the same term, or a like term, right? So let's talk about this. We have 3h squared, and then we have negative 3h squared. So if I had positive 3h squared, and I take away 3h squared, what do I have left? What's 3 minus 3? 0. So what happens? They actually cancel each other out, right? A positive and a negative of the same exact number cancel each other out. Like positive 5 and negative 5 would cancel each other out. Same thing here. We had a positive 3h squared and a negative 3h squared, and they ended up canceling each other out. Okay, I'm going to move on to the next like term that we see. I see h's that are similar here. So I see positive 4h and negative h here. So positive 4h minus h, right? If I combine those, that's going to give me positive 3h. And then do I have any other like terms? I do, right? I have some regular numbers in there, some constants. Negative 5 and positive 8. If I take negative 5 and I add 8 to it, I would get positive 3. Now, is this in standard form? Yes, because the h has an exponent of a 1, so technically it goes before the positive 3 that's by itself because this term doesn't have any variables. So that would be our final simplified standard form there. All right, now moving on to number 3. We have 5x squared minus 3x plus 6 minus 3x squared minus 2x plus 3. Now again, here we want to look, are there any numbers that are outside the parentheses that I want to distribute to make sure that they go in? Well, in front of this, I have positive 1. And we talked about how positive 1 doesn't change anything, right? Because 1 times 5x squared is just 5x squared. We have negative 3x, and we have positive 6. But here I have a negative 1. Now, negative 1 does change your number, right? If I multiply something by negative, the sign is going to go opposite, correct? So we've got to be super careful when there's negatives there. So negative 1 times positive 3x is going to be negative 3x. So it's no longer positive. Negative 1 times negative 2x is going to be positive 2x. The signs are flipping. They're going opposite. Okay, and the negative 1 times positive 3 is negative 3. The most common mistake here is people don't distribute that negative 1 because they don't really pay attention to it. So they drop the parentheses and they copy it down, just like if we were to do this. So I'll show you what I mean. They'll just write 5x squared minus 3x plus 6. They'll put the minus sign, but then copy the exact same thing inside those parentheses. They just drop the parentheses completely. They go boop, boop, and they're like, okay, I'm done. That is not allowed. Make sure you distribute that negative sign if you see it there. Okay, now we're going to go ahead and combine like terms. So I always like to start with the highest exponent first. So I'm going to start with 5x squared and negative 3x squared. Well, 5x squared and negative 3x squared make positive 2x squared. Okay? And then the next like term I see, again, I like to start with the next highest exponent. So it will be negative 3x and positive 2x. Well, negative 3 and positive 2 make negative 1. So this would be negative 1x or just negative x, because we don't have to write the 1 there. And then lastly, I see a like term of positive 6 and negative 3, and that's going to give me positive 3. Now, when I start with the highest exponent, when I combine like terms, it's actually already in standard form because I started with the highest instead of going in order. So usually if you start with the highest exponent and then go work your way down when you're combining everything, then your answer is going to be already in standard form. So we didn't have to move anything around in this one. Okay, number 4. 4z plus 6z squared minus 7 minus 2z squared plus 4z plus 1. So let's go ahead and start with this one. Now, again, with this one has a positive 1 in the front. When I distribute a positive 1, nothing changes. So I have 4z plus 6z squared minus 7. Will it help you to distribute the 1? If that helps you, then do it. Like, if that helps you, I would do it every time. I would encourage it, actually. But if you are able to just recognize that, hey, 1 times anything is just the same thing, then you don't have to do that. Now over here, I have a negative 1. That will change things, so I want to make sure I actually do distribute this through. So negative 1 times negative 2z squared is going to give me positive 2z squared. Okay, I've noticed when grading homework that we're struggling with the negative signs. Make sure you know that a negative times a negative is a positive, and a negative times a positive is a negative, so be careful there. Negative 1 times 4z is going to be negative 4z, and I draw my z's with a line through them because they kind of look like my 2's. And then negative 1 times positive 1 is going to give me negative 1. Once I'm done getting rid of all my parentheses, I can actually just move on and combine these like terms together. So the first like term, I always like to start with the highest. So I see that the highest exponent I have here is a 2. So I'm going to combine those. 6z squared and positive 2z squared. So positive 6 and positive 2z make positive 8z squared. Okay? Okay, the next highest exponent I see here, I like to start with the 4. So 4z minus 4z. I have positive 4z, and then I have negative 4z. Notice how they're opposite. Now, this is an example where they're not opposite, if they're both positive. If they're both positive, they're not opposite, they're the same. So you would do 4 plus 4. But here I have opposites. I have positive 4, and I have negative 4. Well, what happens when I have opposites? Remember, they cancel each other out. 4 minus 4 just cancels and becomes kaput, nothing. Okay, and then the next thing I see is the -7 and the -1, and that's going to give me -8. -7 plus -1 give me -8. And because I started with the highest exponent and went down, this is already in standard form. All right, now number 5, this one's a little bit different from the previous. How is it different? Well, I have numbers in front of these parentheses, so that makes it a little bit different. But does it really change what we're doing or the process? Not really. Okay, we just have something other than 1 to distribute, which is kind of nice for once, right? So we're going to go ahead and multiply this in, and you want to be super careful when you do this because people tend to make mistakes because they forget to multiply, and instead of multiplying, they add. Remember, when you're distributing, it is the operation of multiplication. So you want to make sure you're actually multiplying these. So 3 times 2n squared is going to be 6n squared. 3 times 2 is 6. Oh, sorry, not squared, it's a cubed. Whoops, cubed, it's a 3. 3 times -n squared. Now, there's technically a 1 here, so it'd be 3 times -1, which would give me -3n squared. And then 3 times 5, which is going to give me +15. So I went ahead and I distributed that through. Okay, so you're multiplying the 3 to every single, to every single term. And then in the second set of parentheses, there's a -2 attached to the outside. So -2 times 4n is going to give me -8n. -2 times +3n squared is going to give me -6n squared. Remember, a negative times a positive is a negative. And then -2 times -1 is going to be +2. Now, in this step, I'm going to go ahead and I'm going to start with my highest exponent. Now, my highest exponent here is the 3, right? That's the highest exponent I see. But I notice that there's no other terms I can combine it with, so I literally just drop it to the bottom and be like, okay, I can't combine this with anything, so it's going to be the start of it, but I can't combine it with anything else. And then you move on. The next highest exponent I see is that 2, so -3n squared and -6n squared. Well, -3 and -6 together make -9n squared because we're combining here, we're adding and we're subtracting. So we're adding, combining like terms. Okay? Okay, the next highest exponent would be just the single 1, and that's just the n here, the little -8n. There's no other n's like it, so that's going to go next. And then your regular numbers, your constants always go last because they don't have a variable attached to them. And I notice that I do have like terms here. I have +15 and +2. That's going to give me +17. And again, because I started with the highest exponent, this is already in standard form. So I don't have to think about putting it in standard form. Okay, now with this last one, I do have a star here because there is a special note to be recognized. And we're going to be super careful when we're talking about this. I'm going to go over here and start. Now, we haven't really talked about exponents yet, and we're actually going to learn about that in a couple days, but I'm going to go ahead and talk about the differences between things. Okay, x plus x. If I have one apple plus another apple, I have 2 apples, right? If I have x plus x, I have 2 x's, right? If I have one x plus another x, I have 2 x's. Now that's different. Okay, that's different from what x times x is, and that's the one that we get confused on and stuck on literally all the time. So let's talk about the difference between that. X times x equals blank. Okay, x times x does not equal 2x. It actually equals x squared because I'm multiplying it by itself twice. So let's go ahead and use real numbers as an example here. Let's pretend x is equal to 4. Right, so we're going to replace x's with the 4. So let's do 4 plus 4, right? I'm replacing all these x's with the 4 to show you something. 4 plus 4, well, what is that? That's 8. Isn't that the same thing as 2 times 4? Yeah. Remember, I just replaced all of the x's with 4, right? I took the x, I replaced it with the 4. I took this x, I replaced it with the 4. Took this x, I replaced it with the 4. They're all equal, right? Because x plus x is equal to 2x. 4 plus 4 is equal to 8, which is technically 2 times 4. So I'm just going ahead and replacing that to show you that example. Okay? Let's talk about this in a different light. Let's replace all the x's again with 4s. So now I'm going to replace this x with the 4, right? Then replace this x with the 4. So 4 times 4. Well, what's 4 times 4? 16. Isn't that 4 squared? Because what's 4 squared? It's technically 4 times 4, right? It's 16. So I just did the same exact thing. I took this first x, replaced it with the x. Second x, replaced it with an x. And then I have x squared, which is 4 squared, because I took that x, replaced it with the 4. So Are x squared and 2x the same thing? No, right? In one case I get 8, in the other case I get 16. So when I have x plus x, I have 2x. But when I have x times x, I have x squared. This is super important because we always mix this up. Okay, we always mix this up because we don't think about it that way. So it's just something to think about. I'm just giving you an example because I wanted you to be able to see this in a different way. And then let me go ahead and, okay. And then put an example here. Oops. So these are just real examples to help you out here so you can see and visualize. So x plus x is 2x. But x times x is x squared. So I want to be super careful about that because here we're actually going to apply that. So we're going to go ahead and start. Outside of these parentheses, I got to get rid of, right? I got to get rid of these parentheses. And outside of them, I have a 2m. So 2m times m is going to be 2m squared. Remember, m times m would be m squared, not 2m. And then 2m times 5 would be positive 10m. Okay, remember x times x is x squared. Okay, moving on. We have negative 3m times 2. And I'm going to actually use a different color so that we can see the differences between the problems. Negative 3m times 2 is going to be negative 6m. Negative 3m times negative m, I know that's going to be positive because a negative times a negative is a positive. And then I have m times m again. So I'm going to have 3m squared. Okay, so x times x is x squared, m times m is m squared. And now from this point, once I've gotten rid of all my parentheses, the easy part is just combine the like terms. I always start at the highest, so 2m squared and 3m squared. Well, 2m squared plus 3m squared gives me 5m squared. Okay, and the next term I see are 10m and negative 6m. So these are the next terms. So 10m minus 6m is going to give me positive 4m. So what was the only difference between this problem and the rest? Really not much, just the fact that you have to remember that m times m is m squared. X times x is x squared. You want to be really careful about that because if you do m times m and you write down 2m, that's going to cause a boo-boo, right? Because clearly I proved to you with real numbers that x plus x and x times x are not the same thing. They are not equal, right? X plus x, in one case it gave me 8, right? 4 plus 4 is 8. But 4 times 4 is definitely not 8, it's 16. So be super careful with that. All right, and then lastly, we just have some two-word problems here that we're going to go over, and then we'll be done with these notes. All right, so a rectangle has a length of 4x squared minus 2x plus 7 and a width of 3x minus 1. Find the expression to represent the perimeter of the rectangle. So I'm going to go ahead and draw a rectangle here. I think there's an option on here to be able to draw shapes, but I don't know how to do that right now, so we're not going to deal with it. Okay, so I'm going to go ahead and draw this little rectangle over here. Now we're asked to find the perimeter of this rectangle. Remember, when we're asked to find the perimeter of something, right, it means you want to add up all the sides. Okay, and there's actually two different ways you can solve this problem. One, you can use the perimeter formula, and if you don't know that formula, you can actually find it. So we'll go ahead and talk about how to find that formula first, and then we'll talk about doing that. So this is my rectangle. I know that one side's the width, the other side has to be the width, and this is the length, right? So to find the perimeter of something, right, how do I find the perimeter of something? Well, the perimeter, I would add up all the sides. So I would do W plus L plus W plus L. I would add up those 4 sides. Okay, so let's condense this really quick. W plus W is what? W plus W, right? If I have one apple plus another apple, I have 2 apples, 2W. And then I have L plus L. That's going to be 2L. So this is actually the formula for the perimeter of a rectangle. So I would go ahead and maybe make a note to yourself like, hey, that's the formula for perimeter rectangle. If you forget the formula, can't you just add up all the sides manually? Yes, you can. So I'm actually going to show you the 2 ways that you can actually solve this problem. I'm going to do it one way with the formula and one way in case you forget the formula. So let's go ahead and identify what we know here. Okay, I know that the width of this Do I know the width? Or let's go with the length first since I give us the length first. And I'm going to use yellow since I use yellow. The length is 4x squared minus 2x plus 7. So I'm going to go ahead and label my rectangle with that. Do I really need to? No, but it helps me visualize, so I'm going to go ahead and do it. Okay, so this is 4x squared minus 2x plus 7. So these both have that length because, well, one, they're both the length of the rectangle, so they would be the exact same, right? So these both have a length there. And then it says the width is 3x minus 1. So I'm going to go ahead and label that. 3x minus 1, 3x minus 1. Okay, so these are my width measurements. So I'm going to use the formula. The formula is P equals 2L plus 2W. Remember, perimeter of a rectangle is twice the length plus twice the width because you have 2 lengths you're adding plus 2 widths you're adding. So I'm going to go ahead and plug in the formula. So the perimeter equals 2 times the length. Well, what is the length of this rectangle? The length of this rectangle is 4x squared minus 2x plus 7. And I've told you that anytime you plug something in, you always need to use parentheses. So parentheses, 4x squared minus 2x plus 7. Okay, so 2 times the length plus 2 times the width. Well, the width in this problem would be 3x minus 1, so you want to make sure you put those parentheses there. If you don't put those parentheses, then it's going to look like 23x, so you want to be really careful about that. So then what do you do from here? Just like we've been doing, get rid of those parentheses. Let's go ahead and do that. So we have 2 times 4x squared, which is going to give us 8x squared. 2 times negative 2x is going to be negative 4x. 2 times 7 is going to give us positive 14. Okay. And then I have 2 times 3x is going to give me positive 6x. 2 times negative 1 is going to be negative 2. So all I've done so far is I got rid of my parentheses. And I guess technically we still have p in the front because perimeter equals all of this junk, right? Okay. Now, what do we do for our next step? You would combine your like terms, just like we have for the last previous entire page of notes, right? This is just a word problem, so we're talking about something, but really you're doing the same exact thing that you've been doing, combining like terms. Now I like to start with the highest term first, or the highest exponent, I'm sorry. The highest exponent I see here is the 2 on the 8, and there are no like terms with it, so I would make it go first, okay, but there's nothing I can combine it to. Okay, the next thing I can see that I can combine, that's the next highest, is the x's, negative 4x plus 6x. Well, negative 4x plus 6x gives me positive 2x. Negative 4 plus 6 is positive 2. Okay, and then my next thing that I can combine is the positive 14 and the negative 2. Positive 14 and negative 2 give me positive 12. Okay, so my perimeter is 8x squared plus 2x plus 12. You're like, why didn't it give me a nice number? Well, because they didn't give us what x equals to. So it's set to find the expression, right? It's set to find the expression. So you should expect to see something kind of weird that's not really like a number answer. Now let's say you forget the formula, right? Like you forget 2L plus 2W, so you have to do this the manual way. So we're going to use this way, where we add them all up individually. So the perimeter equals the width first. So let's go ahead and do the width. Oops, I don't know why I labeled the, let me fix things real quick. Perimeter, this should be blue. This should be blue. That blue, this blue. Sorry, I gotta make sure it's color coded correctly because then it doesn't make any sense really. There we go. All right, so let's go ahead and use that first formula where I talked about, hey, let's add up all the sides. So the first thing I would add up is the width. So what is the width? The width is 3x minus 1 plus the length. Well, the length is 4x squared minus 2x plus 7 plus the width again, right? So the width again is 3x minus 1 plus the length again, lastly, right? Because we're using this first formula here. We're adding the sides up individually. 4x squared, whoops, wrong color. 4x squared minus 2x plus 7. All right, so this is what I have in total here. Now what would I do? It's some giant thing, but now we're going to combine all the like terms together. So here we go. All right. I'm going to start with the highest exponent first, and the highest exponent I see here are the 2's. So we have positive 4x squared and positive 4x squared. Well, positive 4x and positive 4x make positive 8x squared. Okay? Oops. Okay, the next highest exponent I see are the x's. So I have 3x minus 2x plus 3x minus 2x. So let's go ahead and combine those. So 3x minus 2x is going to give me positive 1x. And then I add that to the 3. So 1 plus 3 is 4x. Right, we're combining these. So, whoops. These two together would make 1x, and then I would add 3x to it. That would give me 4x, and then I would take away another 2x, which would give me 2x. So you're just doing 3 minus 2 plus 3 minus 2. So that's a complicated way of saying that, all that stuff. So 3 minus 2 is going to give me 1, plus 3 is 4, minus 2 is 2. So I have positive 2x. And then lastly, I have all my regular constant numbers. So negative 1 plus 7 gives me 6. Minus 1 gives me 5, and then plus 7 gives me 12. 5 plus 7 is 12, so I have positive 12 here. Did I end up with the same exact answer I did earlier? Yes, I did. So does it really matter which way you do it? No. One probably takes a little bit less time, one takes a little bit more time. It is whatever you prefer. All right, then we're going to move on to this last problem, which is similar to something in your homework, so it is important that you pay attention. The perimeter of a quadrilateral is 15x minus 1. Three sides have the following lengths: 2x plus 7, 6x minus 2, and 3x minus 7. What is the length of the fourth side? Well, this says it's a quadrilateral. Now, I don't really know what the quadrilateral looks like. I just know that a quadrilateral, hopefully you know, that a quadrilateral has 4 sides. It doesn't really tell me what those 4 sides are, so I'm just going to draw a weird shape that has 4 sides. Does it really matter what my shape looks like? Not really. I just need something with 4 sides. Now, it says that the perimeter... It's saying that the perimeter is 15x minus 1. So go ahead and write that down. P equals 15x minus 1. Okay? And then it tells me I have 3 sides of the following lengths. It says I have 2x plus 7, so I'll go ahead and put that on one of the sides. 2x plus 7, 6x minus 2, and 3x minus 7. And then it says, what is the length of the fourth side? The fourth side is the thing that we do not know, question mark, right? I'm going to put a question mark there because I don't know what that is. So I have 3 sides, but I don't know that fourth one. Well, let's go ahead and think about all the information they just gave us. They gave us the perimeter. Well, what is the perimeter and how can I find the perimeter of a shape? Remember, finding the perimeter of a shape is adding up all of the sides. So let's go ahead and add up all of these sides. So we have 2x plus 7 plus 6x minus 2 plus 3x minus 7 plus that fourth side. We don't know that fourth side. I'm going to leave it as a question mark. So I know that if I add up all 4 of these sides, what should it equal? It should equal the perimeter. Well, what's the perimeter? 15x minus 1. Again, to find the perimeter of a shape, you add up all the sides. So I'm taking the 4 side lengths that I know, or the 3 side lengths that I know, and then the missing one that I don't know. If I were to add them all together, it should equal 15x minus 1. So now we're going to solve this. So the first thing I'm going to do is just, hey, let's just simplify this down because it's kind of messy. So this is an equation, so you can only combine stuff that are on the same side of an equation. So the 2x can be combined with the 6x and the 3x. So I'm going to go ahead and combine those together. 2 plus 6 is 8. 8 plus 3 is 11. So I have 11x here. 2 plus 6 is 8. 8 plus 3 is 11. And then the next side that I can combine, or the next term, I'm so sorry, is 7 minus 2 minus 7. Well, 7 minus 2 is 5, right? 7 minus 2 is 5. 5 minus 7 more is going to give me negative 2. So if I were to combine all 3 of those blue highlighted terms together, I would get negative 2. Now, I don't know the last part. It'd be plus question mark, right? We don't really know what the question mark is. We just know that it's there, but we don't know anything really much about it. Well, again, what's the goal of this, right? What's the goal of this problem? I'm asked to find the length of that fourth side. Well, how are we representing that fourth side right now? We're representing it by a question mark. If we're looking to see what the question mark is, we've got to get the question mark by itself because we're trying to figure out what that fourth side is. So how would I do that? I got to get the question mark by itself. So let's think about this. What do I need to do? Well, the first thing I'm going to do is I'm going to move the 11 to the other side. If I want the question mark by itself, I need to move literally everything else to the other side. So I'm going to move the 11x first. Because it's positive, I would subtract. And you can only subtract from like terms, so I would subtract it from the 15. So 11x minus 11x goes away. Okay, so what do I have left? I have negative 2 plus question mark equals 15x minus 11x is going to give me 4x minus 1. Okay, so here I am trying to figure out, hey, what's the question mark? That's the thing I'm trying to get by itself. So I'm trying to get the question mark by itself. It is not by itself yet, so what's our next step? Well, the next thing I can do to try to get it by itself is I can add the 2 to both sides to get rid of that negative 2 because it's the opposite, right? We want to get rid of it. And I would add it to the negative 1 because those are the like terms. So what does that mean? My question mark is now by itself. And it equals 4x, and the negative 1 plus 2 is going to give me positive 1. What does that mean? Okay, what does this mean? It means that the length of the fourth side is 4x plus 1. So this one was a little bit tricky. You have to work with the information they give you. So there is a similar homework problem, so just make sure you're prepared for that. If you have any questions,